Okay, version 4.2. This stuff is always a lot harder than it ever seems. And little bugs creep in and some stuff just doesn't work. One of the challenges I think has been uploading to the Arduino. I don't seem to ever have any trouble with it, but apparently lots of people do. So tried to make some changes here. And WAS 0, or the wheel angle zeroing, on factory it's never right at 0 at 2.5 volts, and you can't adjust it. So this is just a little paragraph on how to calculate it. I've doubled the A to D converter now, so now it goes from that 3320 is now the middle instead of that 1660. So 3320 is now the 0 minus the 127 is 3193. So that then becomes your 0 point. And it's written there. Now you want to change it. Again, just read that, and it's fairly straightforward. You just multiply the voltage times the 1288 counts per volt, and then you subtract it from the 3320, and you get your new 0. Can discuss that more on the forum. Every INO has a version number that matches AgOpenGPS. So the version in AgOpenGPS is 4.2.01. Want to write that to EEPROM, so just get rid of the decimal places. And up here you can see that the name is AutoSteer USB 4201. And then we add up all the numbers, and that becomes the AOG version. And that number gets set back to AgOpenGPS. And if AgOpenGPS doesn't see this version, then it kicks you out and exits the program. So you have to load the correct INO before AgOpenGPS will even work now. So no more fudging it with old Arduinos, and not going to have to ask anymore, have you uploaded the new Arduino? Because if you haven't, it won't even run. So that hopefully gets around that. All right, just going to upload this, and it's uploaded. Okay, AgOpenGPS. Not a lot has changed, but you'll see these two numbers down here. They are a checksum. That is, all of these values are added up into a byte, and then as the byte runs over, it doesn't really matter because this is just basically a checksum of adding up all of these things. That is sent to the Arduino, and then the Arduino, when it receives it, it adds up all the values that it received, comes up with a number, sends back its version, remember that 7, and what the total of that received byte was, and these two need to match. If that doesn't match, it pops a little they didn't match, and that's where then you know something's wrong. They also will turn red if it doesn't match. But we'll see that more here in a bit. So this is starting from absolute square 0, just like that. Get rid of this. So here we have AgOpenGPS now. Of course, first thing you do is attach the serial port, connect, and there it is. Next thing, of course, you do, you send off your module configuration, make sure all this stuff is right. Let's change that to 3. Now you can see the check matches the return because we haven't sent anything, we haven't done anything. As soon as we hit send to module, see these two are the same. We sent a checksum of 212. That's what we got back from the Arduino. So we know, well, you don't never know 100%, but you're pretty sure that that's what we sent and that's what we got back from the Arduino. So it received that. If it comes up 212 and that says 0 and it's red, well, then you know something is wrong. The other new thing is this Invert Relays that allows you to invert the relays, but we'll talk about that more in the machine part of it. But basically you check that and it inverts the relays instead from active high to active low. All the rest is the same. And we sent that to the module. So if we change this to 2 and send it, see it's a different number. Change this to MMA1C, it's a completely different number. So as you change things, it comes up with a different checksum. So this is a really good way to make sure that it gets there. Whoops. Now the other one, of course, is the AutoSteer settings. Now I've changed this so that the buttons and everything are at the bottom. It was kind of frustrating. Well, it was really frustrating. You always had to go back to that drive tab to change anything. So this is the initial setting. Proportional gain of 0, minimum drive is 0, max of 100. This is new, and this is new, a dead zone. We'll talk about those in a sec. Steer comes up at 0, this is at 10. So just the very basic settings initially. And it will not work because the proportional gain is 0. The other thing got rid of is that output gain. So now it's just one single slider that goes from 0 to 200. So as soon as we move something, you see it turn red for a sec. It just like the Arduino settings, this is what we send for checksum, this is what gets back. So if we move this up to 26, that sort of thing. The other thing it does now is it waits about a second or a second and a half before it sends. Previously, anytime one of these things changed, it would just send a million times a second. It would try to update the Arduino. I don't know if that was causing problems or not. Again, I never saw any of those kind of problems, but it's not like they weren't happening. So hard to fix something that I can't replicate. But this is just one more way to try to prevent them. So let's turn all this back down again. The other thing you'll notice over here is on the screen is this little red dot. Let's bring up the webcam. I don't know if you can see the switch or not. Can't, but I'm going to turn on the switch. You'll see this guy turn. And now he's green. There's an LED here that's tied to PWM2. Now that can be used to drive a relay, it can drive an LED. It's unused with the Citron. With the IBT, it's used as the enable. So, if we hit drive here, this is the actual, this is the set point, and this is the difference between the two. Got rid of the bars. They were so slow, they were kind of useless anyway. And so now it's just buttons to set it up and down. There's still a 0. And of course drive off and on. If you don't want to use this, you can hide it or show it. It's up to you. But the thing is you can adjust these while you're adjusting it in the drive mode. Okay, with proportional gain of 0, 0 times error is going to be 0. So the actual, this is the number in there is the actual pulse width modulation value that's sent to the motor. So we crank up the proportional gain, say 20. Okay, so adjusting PID values. Again, the little green dot, that's when the auto steer is enabled, but not necessarily running. If all the criteria are met, like right now we have it in drive, we turn drive off, then the pulse width modulating 2 line, it goes low. So if everything is ready for it to drive, then that'll turn green. Okay, let's talk about some of these settings. Proportional gain, there used to be 2 of them, proportional and output. Now there's just a single one. The minimum drive, that's the baseline or minimum amount of drive to the motor. That's as low as it gets. So if it just tries to overcome the friction of the motor and a bit of the steering and that sort of thing, so that when you add a bit of proportional gain, it immediately turns right away. Max is the maximum amount of pulse width modulation. Like here's wide open, so it's motor fully open, halfway. So when the pulse width or the gain and that sort of thing gets up to 120, that's where it'll stop. So you can set your motor fairly high gain, but then it won't go crazy either, because, well, you can just limit how fast the thing goes. Dead zone, if you're within, say we set this to 1 degree, then if you're within 1 degree of your heading, then it just stops the motor. And until it's 1.01 degrees, then it will introduce proportional gain and that sort of thing, and then steer the motor. Haven't used this out in the field, but I think it really has promise. Wheel angle sensor, again, as we move that back and forth. Here, let's give these guys a little bit of little encouragement here. Go to 10. Turn our max down because it's just a little motor. Leave that at 0. So as we move our wheel angle sensor, you can see that it moves the actual position. Now this is going to be even fussier than it was before because now we have twice the counts. Put that in the center. So that's how you center as you drive along. Move that back and forth a bit to make sure the thing drives straight. And if it doesn't, if you're all the way one way and it's still curving that way, then you need to adjust your wheel angle sensor. As a very absolute last resort, don't adjust the INO, but put your wheel angle sensor in the middle, do a really good job, make sure everything's tight, there's no slop in anything. Make sure that you can adjust it with this wheel angle sensor, because if you can't, it's a bad insulation, and you need to do something to fix that. Counts per degree, there's 6,000 counts, and you can do, say, 100 degrees, then that's 60. The higher this is, the farther it will turn, because it takes more movement of the wheel angle sensor before it becomes 1 degree. Max steering angle, well, that's pretty obvious. And side hill draft, what that does is based on roll, it introduces a bit of a turn, an additional turn, to help you turn up the side hill. And Pure Pursuit and Stanley, these guys just play with them. That brings up a steer chart. Then you can steer or select Stanley or Pure Pursuit. Now let's talk about these guys. This is just a motor connected to a potentiometer, and the potentiometer connected to the motor. And this is basically like your steer motor or your valve or that sort of thing. And this is the wheel angle sensor, and the two are connected. This is a very short connection. You have tie rods and steering gear and all sorts of other stuff interconnected between the two, and there's a lot more delay. But everything works basically the same. If we have a proportional gain of, say, 10, and we zero this out, you can see that it takes time to get there. Let's put that at 40. So if we crank this up now to, say, 40, we get more gain based on the error between the two. Let's turn this down. So as we get an error, we see we never quite get there. So we say, okay, well, let's turn up the gain. Now it goes too far. Well, let's turn it up some more. Turn up our max pulse width modulation. There you see now it overshoots, and then, now it just starts to wiggle and oscillate back and forth. So in our quest to try to make it faster, it becomes unstable. Now, this is the same thing whether it's a small motor or a big motor. What you want it to do is get there fast enough, but not overshoot. There's not too bad. But you see, once we start to add some minimum, let's add 23 to the minimum. Now let's do a jump. Roll. Let's start to slow this down. You see, start to tame. So you see how sensitive that is. Even just 1 or 2. Still too much. Turn out a couple more. See, that's getting pretty good. It finds it right away. There's 0 error. And we can even turn this guy, the max pulse width, down. See, that limits our motor speed. That's just like a motor that just goes too slow. So if you see that nice straight line, let's do that again. Watch this number over here. That's the max pulse width. See, there's our 44. That's exactly what we set. So you can see that setting these is just a combination of guessing. Like how fast we want our motor to turn. What is our minimum before the thing actually starts to turn, that sort of thing. So if we crank this up now, see now our motor's faster. And it's right there. Remember, this was at 40. So if we turn that way down, see, it's completely different again. Fair error. So if we turn this too high, it reacts too fast. See, it becomes a bit unstable. In a tractor setting. So that's all you can do is keep kind of playing and just get a feel for it. Let's turn everything back down again. You know, the easiest way is crank this guy up. Well, maybe not that high. But how fast do you want your motor to turn? Like, that's fast enough. So then that's how you set your max pulse width. Is how fast do I want that motor to turn in order to make a U-turn, but not overdrive. So again, now we'll use it back to 0. We know that's a little crazy. So then kind of our max should be, you know, back at that 90 sort of thing. You know, it reacts fast enough, but not too fast, and not completely out of control. So then our proportional gain, you know, you can just play with it. And then this minimum one is very important. This one is absolutely critical. Because if we have it here at 5, I'm sitting at 40. Right? If we take it up a little bit more now, then it locks right in there. You make it too high, and then it starts to oscillate back and forth. Make it even a little higher. It's very sensitive. That's the thing. So we'll put that at 20, and it becomes obvious. So in a field situation, you don't want the thing wiggling and woggling back and forth. Actually, let's take it up here for now. Let's talk about the dead zone. Now what the dead zone does is the difference between these. Say we'll put that at, say, half a degree. And now when we do this, let's turn this down so we get some air. Of course, it's going to work every time perfectly. There's 0.2. As long as it's less than the half a degree, there will be no pulse width modulation to the motor. Let's turn this down. There. You can still hear the motor because he's just not enough. But I think you get the idea. No, it's still not enough. See how tricky it is? Especially if you want it to there, 0.3. So as long as it's less than the difference between these is less than 0.46, then it will just plain shut off the motor. So if you're heading pretty close to the line, there's no point taking the steering wheel and wiggling it back and forth if you're already going straight. So that's what this dead zone does. If you put it up to 1.5 or whatever, you know, it takes 2 to move. You know, go back to 0 and then it's on all the time. See, it's at minus, I see at minus 10, back 12. So you can see how you can go from just an absolute wiggly woggly mess, you know, to something that works really, really well. All in a couple clicks. Like, just you can just have a really bad day, you know, just because you move these one or a little bit too far the other way. The other thing that can really affect things is your counts per degree. If you're not utilizing that whole wheel angle sensor, say it's really short, there, just by changing the counts per degree, all of a sudden it's unstable because it has to react too fast. Just like that, quietens right up. So all of these things, I mean, there isn't that many. Now there's just proportional gain, your minimum drive just to overcome the minimum resistance, and the dead zone. I'm not sure how that's going to work, but really it's just these three. And of course your counts per degree. And of course your zero. But once those are set, those are fixed. So really you're just dealing with your max pulse width, your minimum pulse width, just to get that motor going, and how fast you want to get there, and how fast you want to limit the speed of the motor. And that's it. So I hope that demonstrates a bit of what these settings do. I think when you have a better understanding of what they do and what their effect are, then it becomes much easier to set. So yeah, looking forward to just a couple of guys are testing version 4.2, and I hope it has solved some of the problems. Okay, I want to talk a little bit more about this checksum, and what I've done is, normally we just add all these up, but I'm going to add 5 more to it, and I'm going to upload this. Okay, so now we go into our steer settings, and if we move one of these now, see, we added that 5, so we sent 34 and received 39, so it's a checksum error. We go, okay, and it stays red. We know we have a problem, and that's the error that comes up. So we try again, still an error. We know that something is wrong because what we're sending isn't what we're getting back. Okay, so we'll take this line out now. That was our adding of 5. What we'll do is we'll mess up what we will do is we will not send a AOG version, we'll send a 3. Now we'll upload that. So now we have the wrong version. Okay, so that's uploaded. Connect the port again. And now we bring this up and we try to change something. It'll say INO is the wrong version, upload the correct version. Okay, ag open GPS exits. So no mercy there if you're loading the wrong version. Just wanted to add that.